Welcome back. The objective of this video is to introduce geometric sequences. A geometric sequence is any sequence with a constant ratio between consecutive terms. So in arithmetic sequence, it was a common difference, but now we're looking at the ratio of the consecutive terms. So with a starting value of a and a common ratio r, it follows the form a times r to the first, and then the next one's a times r to the second, and so forth. So here's an example of a geometric sequence where our ratio, we can calculate our ratio is 8 over 4, and that's equal to 16 over 8, right? Our second term divided by our first, our third term divided by our second, our fourth term divided by our third. So our common ratio here is 2. So the nth term, or general form, of a geometric sequence with a first term of a sub 1 and a common ratio of r is a sub n equals a sub 1 times r raised to the n minus 1. Now be careful with your order of operations here. We're only raising the ratio to that particular power, not the first term. So that first term is going to be a multiplier in front of that ratio raised to a power. I've already talked about the common ratio. We saw that. So the common ratio is just second term divided by the first equals the third divided by the second, and so forth. And then each term in a geometric sequence can be obtained recursively from its previous term by multiplying by our ratio, or r. So we've got our general form. We've got the kth term formula, which says that g sub n, some term, the value of a particular term, so right now we've done it as the first term, equals g sub k, the value of some term, times r raised to the n minus k. So g sub k would be the value of a different term, and then n is the place in order, the place in the sequence of the value of the nth term, and then the k is the location of the value of the kth term. So the n might be the fifth term, the k might be the eighth term, and they have particular values. We will use this geometric mean business in a geometric sequence, a times b times c. b is equal to the square root of a times c. So like if we're missing or skipping a term, we can find the one that's halfway in between by taking the square root of the ones on either end. So if we're missing the second term and we have the first and third, we can use that formula. So we'll see that in some of our sample problems later on. In our sample problems here, they're just asking to identify whether it's a geometric sequence or not, and to find the common ratio of r. I think we're going to take that one step further, and we'll also find, the formula for that particular sequence, if it is one. So we'll go ahead and do that. So in A, we have 3, 6, 12, 24. So 6 over 3 is equal to 12 over 6. So our r is equal to 2. And our first term, our a sub 1, is equal to 3. So our formula, a sub n, is equal to 3, our first term, times 2 raised to the n minus 1. So I have to do n minus 1 because if we have the first term, 1 minus 1 is 0. Anything to the 0 power is 1. That'll give us the value of 3. In sample B, let's check our ratio. Can we do negative 9 over 3? Does that equal 27 over negative 9? It does. So our r is negative 3. Our first term, again, a sub 1 is equal to 3. That's not always going to be the case, but it seems to be a popular one in our sample problems here. So our formula is a sub n equals 3, our first term, times negative 3, again raised to the n minus 1. because when n is 1, negative 3 to the 0 power is 1, we get 3. And then when our second term, we go 2 minus 1, so we get negative 3 to the first power, so that's negative 3 times 3 gives us a negative 9. That formula is going to work. In sample C, we're checking for an R of 5 over 1. Does that equal 9 over 5? It does not, so this is not geometric. In fact, it looks like we have a common difference of 4. This is an arithmetic sequence. And in sample D, we'll look at negative 12 over 48. Does that equal 3 over negative 12? So our ratio is negative 1/4. Our first term is 48, so our a sub n is 48 times our negative 1/4, all raised to the n minus 1. And that wraps up the introduction to geometric sequences, and you'll get some more practice with this when I see you in class.